In this topic, we've seen how flow diagrams can be useful when you're learning how a system operates. We've also looked at a couple of examples of how flow diagrams can help you line up valves in a system. Try some practice questions now on what we've covered in. Electrical systems play a vital role in the operation of an industrial facility. They provide power needed to operate lights, control panels, and process equipment. The wiring in electrical systems provides flow paths for electricity throughout a facility. Like other plant systems, electrical systems can be represented by diagrams. Electrical diagrams provide information that can help you follow the route of electricity through system components and understand how the flow of power is monitored and controlled in a system. Although there are several types of electrical diagrams, we'll focus on electrical one-line diagrams. An electrical one-line diagram, such as this one, represents an electrical system or a section of an electrical system. This diagram represents a load center or main bus with 3 load circuits connected to it. A bus is a common conductor that connects a power source to several load circuits. Each circuit or power transmission path is shown on the diagram as a single line. We'll identify the components in this system as we trace the power transmission path on the diagram. Let's begin where power is supplied to the system. The main transformer reduces the voltage of the power supplied to the system. This power is then supplied to the load center. The load center supplies power to the 3 individual load circuits. These circuits in turn supply power to specific loads. Let's look at the circuits connected to the load center one at a time, starting with this one. The first component in this circuit is a circuit breaker. The main transformer reduces the voltage of the power supplied to the system. This power is then supplied to the load center. Breakers are opened to isolate a circuit and closed to energize a circuit. After the circuit breaker, power passes through a power transformer. A power transformer converts the relatively high voltage from the load center to a lower voltage for the equipment fed by the circuit. In this case, the transformer changes the voltage from 480 volts to 220 volts. From the power transformer, power flows through another circuit breaker and then to a circuit that supplies a lighting panel that supplies power to several lighting circuits and to a sump pump motor. These symbols represent breakers that can be used to isolate the lighting panel and the sump pump motor, respectively, for maintenance. The breaker in the sump pump motor circuit is also used to start and stop the motor. Now let's follow the power path through the next circuit connected to the load center, the one for the mixer motor. The mixer motor circuit actually includes 2 circuits, a power circuit and a control circuit. In the power circuit, power passes through this circuit breaker and this contactor to the mixer motor. In the control circuit, 3 components are shown. A potential transformer reduces voltage, a fuse interrupts the flow of power in the circuit if the current in the control circuit gets too high, and a start-stop switch is used to operate the motor. The arrow indicates that the start-stop switch operates the contactor to start or stop the motor. The last circuit connected to the load center supplies power to a motor control center. The first component in this circuit is a circuit breaker. This breaker can be opened to isolate and de-energize the entire motor control center. From the circuit breaker, power flows through a current transformer. The current transformer produces a small current that's used by the ammeter. The ammeter provides an indication of the total current flow to the motor control center circuit. Power then flows to the motor control center. A motor control center is basically a bus that supplies power only to motors. This motor control center includes 2 identical motor circuits. Each motor circuit includes a power circuit and a control circuit. In each power circuit, power flows through a circuit breaker and a current transformer, then to a motor contactor, and finally to a motor. The ammeter connected to the current transformer in each motor power circuit indicates how much current the motor is using. Each control circuit has a potential transformer, a fuse, and a start-stop switch. That completes our look at the paths and components in this electrical system. Before many kinds of maintenance can be done on plant equipment, the equipment must be isolated. For electrical equipment, this means separating the equipment from the supply of electrical power. To get an idea of how electrical diagrams can help when you need to isolate equipment, let's look at an example. In this example, the feed pump motor has to be shut down for repairs while the rest of the system remains in service. On the diagram, we can see that the feed pump motor is fed by motor control center number 3. However, the motor control center also feeds the transfer pump motor. We must isolate the feed pump motor in such a way that the transfer pump can continue to operate. By tracing the power path back from the feed pump motor, we can find the breaker that's used to isolate the feed pump motor circuit. Opening this breaker isolates the feed pump motor while the other motor in the system remains energized. In many cases, components represented on an electrical one-line diagram are numbered. The diagram we've been working with shows how component numbers may appear on a diagram. You can use the ID numbers to verify that you've found the right component by matching the number on the diagram with the number on the component in the plant. In our example, the system diagram helped us isolate one component without disturbing the rest of the system. By tracing the power path back from a component, we can find the breaker that's used to isolate the component from its power source. Opening the breaker isolates the mixer motor. The diagram we've been working with represents a relatively simple electrical system, but by now you should have a good idea of how to use a diagram to learn how power in a system is distributed and used, and how equipment can be isolated. Take some time now to practice what you've learned in this topic.